Hello, I'm Chad Boyd, Rangeland Scientist at the Eastern Oregon Agricultural Research Center. It's often said that good riparian management should, particularly in meadow streams, promote narrow, deep stream channels. However, we don't often talk about why that should be the case. Narrow, deep channels can increase water storage and aid in stream bank maintenance. The shallow, wide profile of degraded streams may cause a drop in the water table within the surrounding riparian area, leading to drier site conditions and the potential loss or reduction in the abundance of riparian plant species. A degraded stream profile can contain a stream and keep it from accessing its floodplain during high flow. This in turn impairs the ability of the stream to dissipate energy and impedes bank maintenance via sediment deposition. Additionally, narrow, deep stream channels minimize the amount of water surface area exposed to the sun, which helps moderate summer temperature extremes. The deeper cross-section profile can improve structural complexity of the channel with features such as undercut banks that improve habitat quality for a variety of fish species. One of the most common chores in rehabilitating degraded riparian systems is the planting of willow cuttings. Careful selection of planting sites can help increase the success of these efforts. One of the most important factors influencing the survival of cuttings is water table depth. Recent research in our area suggests that groundwater tables should remain within 15 inches of the bottom of the cuttings. If planting depth is approximately 15 inches, then the depth to water table should not exceed 30 inches during the growing season. Maximum water table depth can be easily measured by simply digging a hole during the driest portion of the active growing season, which is generally August. In riparian habitat grazed by livestock, survival of cuttings can be increased with early season pasture use, for example, use in June. With grazing later in the season, plants may be stressed due to a lower water table combined with a shorter recovery time prior to the end of the growing season. Additionally, livestock may browse willows more heavily if grasses and sedges have already cured. One of the most contentious issues surrounding livestock grazing in riparian areas is end-of-season stubble height requirements. We often hear that a particular minimum stubble height is needed to trap sediment during high flow and encourage bank building, helping the stream channel to develop over time. However, field research on the influence of stubble height on sediment deposition has produced unclear results, and most studies to date have been conducted in artificial stream systems. Despite the ambiguous nature and artificial context of the scientific research, stubble height can provide a useful index of grazing impacts on riparian plants, particularly when timing of grazing is also taken into account. Additionally, it may relate to other variables such as bank damage from trampling. Most importantly, it keeps managers looking at the resource. Woody plants such as willow and alder benefit riparian ecosystems by improving channel stability and providing habitat for numerous wildlife species. Additionally, it is often assumed that shade from these plants will help to moderate summer water temperature extremes. However, research in Eastern Oregon has produced mixed results. One often overlooked factor when considering the impact of woody plants on stream temperature is position in the watershed. As water moves downstream from the headwaters, it is generally warmed by the sun, the same energy source that causes the air temperature to increase. If water flows far enough, its temperature will eventually reach a point where it is in balance with the temperature of the air and that of the soil surrounding the stream. This is called thermal equilibrium. As stream temperature approaches thermal equilibrium, shade is less effective at moderating water temperature. What this all boils down to is that shade may have less influence on stream temperature with increasing downstream position in the watershed. Recently, we have seen considerable interest in the management of sagebrush obligate wildlife species. It started with the greater sage grouse and picked up steam with the pygmy rabbit. The problem is that there are additional sagebrush obligate species that have yet to take political front and center. At some point, we may have to ask ourselves if the single species approach to management is a good fit with the complexity of the situation. We need answers to questions including, is it logistically possible to have multiple species management or recovery plans operating on the same piece of real estate at the same time? Or do we have the time, money, and people power to repeat massive planning efforts for all sensitive sagebrush obligate species? Answers to these questions are difficult at best. One ironically simple alternative would be to take a more collective approach and focus less on individual species and more on providing healthy, functioning sagebrush plant communities across the landscape. The assumption being